Okay, we're back here for another video on the quadratic formula. Just to recap, here's your formula. X equals negative b plus or minus radical b squared minus 4ac all over 2a. Don't get confused by those letters. They're just variables, but they just represent numbers. And they come from your quadratic formula, your equation. A is your coefficient of x squared, b is the coefficient of x, and c is your constant all by itself. Before we get into some examples, let's review one more time. Reducing radicals. If I'm reducing radical 32, I change that to be 16 times 2, which is 4 squared times 2. The square of the 4 and the square root cancel. The 4 comes outside is 4 radical 2. Reducing radical negative 50, that's going to be an imaginary answer. That's negative 1 times 50, which is negative 1 times 25 times 2. Negative 1 times 5 squared times 2. The square and the square root cancel to give you just a 5 on the outside. The negative 1 is your imaginary piece that comes outside, and the radical 2 stays, so 5i radical 2. Same thing over here with radical 100, but 100 is a perfect square. So the negative 1 comes outside as your I. The square root of 100 is just 10, so 10i. Let's do an example with the formula. We've got 11x squared plus 8x minus 10 equals negative 11. Let's get it equal to 0 first. So add 11 to both sides. To get 11x squared plus 8x plus 1 equals 0. And now with me, I always like to do graphical first and then compare it with the algebraic. So let's go to that graph. Let's check it out. I've got typed into the y1, 11x squared plus 8x plus 1. So here's my quadratic already typed in. Let's hit graph and see what it looks like. Looks like this. That graph's kind of hard to see, so I want to play with the window a little bit, but I want to use zoom because I really care about right here where we touch the x-axis. I can see I touch it twice, or the graph touches it twice, but I want to see it better. So I'm going to hit zoom, zoom in. Okay, so number 2, move my cursor right there to where that vertex is, hit enter, and notice how much better my picture gets. And I can zoom in as many times as I want to, but this is pretty decent right now. I can tell that this graph touches the x-axis 2 places, so I know my answers are real, but I don't know if they're rational or irrational until a little bit later, but I can go ahead and find my answers. Second trace. Key word here, remember, x-intercepts, solutions, zeros, and roots are all the same thing. So 0 is the word I want. Move my cursor to the left side of my intersection. It's going to be above on this case. The right side of my intersection is going to be below on top of the intersection. And I get an answer which looks kind of ugly, so it's going to be irrational. It's a negative 0.567 if I round. Finding the other one real quick. Second trace. Again, keyword is 0. Move to the left side, which is below in this case. So about right there. The right side is above, on top of, enter, and another decimal, so another irrational, x equals negative 0.160. So 2 very, very ugly answers. So 2 irrational but real answers, solutions. Before we go back and compare this algebraically, let's talk to you about what would happen. Let's say you do this and you get an error. I'm going to do this incorrectly and show you a very common error. Let's say I go through my 0 process and I think this is my left side and this is my right side. And then I hit enter. When you see this error right here, it says bound. Anytime it says bound error, that means you got your boundaries mixed up. You mixed up your left and your right side. So just go back and switch them. Okay, so try that. Don't get frustrated. Just realize bound means your boundaries were flipped. Okay, let's go check this algebraically. Quadratic formula. This is my A, my B, my C. So x equals negative b, so 8, plus or minus b squared, so 8 squared, minus 4 times my A and my C, 11 and 1. Times 2 times my A. Again, it starts off looking really big and really ugly. We're going to use our discriminant to simplify. So x equals negative 8 plus or minus a tiny radical over 22. You can type in just the numbers under the radical, just the b squared minus 4ac part, and get a tiny number that's going to help you reduce this real quick. It becomes 20. Now, why is that important? 20 is your discriminant. 20 is perfect. It's not a perfect square, but it's positive. So not a perfect square, but it's positive. That means two real but irrational solutions. And we just found them. They were irrational. They were not pretty answers. So we know we're correct. Let's keep going. To reduce this here, we've got to reduce this radical. So radical 20, well, we know that's going to be 4 times 5, which is going to be 2 squared times 5. The square and the square root cancel. So the 2, and then a 5 stays inside. So 2 radical 5 is your reduced version. Let's use that in this problem. X equals negative 8 plus or minus 2 radical 5 over 22. This is your answer, but you've got a few more steps to make it match what most common tests have you do. You have to reduce. Look at 8, 2, and 22. 8, 2, and 22 are all even. They're all divisible by 2's. So negative 4 plus or minus 1 radical 5 over 11. That's an equivalent answer. That's what most tests are going to have. The only other version you could have is they might split it up. Use your plus sign for one answer. Use your minus sign for the other answer. Notice I didn't put the 1 in front of my radical. You don't have to. It's still equivalent. And these are your actual irrational answers. Now, you may be thinking that doesn't match what we got graphically. It does match. If you would type this in the calculator, it would give you the equivalent to one of those decimal answers. So they do still match graphically and algebraically. Okay? So in the first video, we did real rational answers. This video was real irrational. The next problem, let's look at some imaginary. So we've got this problem. Again, you've got to set it equal to 0 first. That's very, very important. That's crucial. Add 5 to get 7m squared minus 4m plus 9 equals 0. Let's go back to that graph, that screen, and let's clear out what we got in there. So second mode to quit. Go back to y equals. Let's take this quadratic out. Let me wipe my screen off for a second. Okay, let's put in there our new quadratic, which is 7x squared. I know it's m's, but you got to use x's. Minus 4x plus 9. Let's zoom 6 to go back to a standard window and see what our graph looks like. And you may think you don't see it, but it's right here. It's up here hidden. Okay, we can fix our window so you can see it better. I'm going to go back and play with this a little bit. I don't want all this negative y, so I want to put 1 here for a negative y value. Let's make this 50 for a y max, and let's count by 5s. Let's graph it again. So there's your quadratic. But here's what I want you to notice. If you can see the quadratic, there you go. This is your x-axis right here. Does this quadratic touch the x-axis? No. Therefore, you can't have real answers. This is going to be 2 imaginary answers. Okay? No real, 2 imaginary. Well, there's a good and a bad to that. The 2 imaginary means you can't find the answer here by second trace. It doesn't touch the x-axis, so there's no real zeros. But you can still do it by hand, which is why we make you learn that big quadratic formula. Let's go do that. So here we go. We got our A, our B, our C. X equals negative b, so negative, negative 4, plus or minus negative 4 squared minus 4 times 7 times 9, all over 2 times 7. Let's simplify. A negative negative makes for a positive. 2 times 7 is 14. Again, I left the discriminant a little bit blank for now. You're going to figure it out in the calculator, or you're going to do it in your head, either or. When you do this, you're going to get a negative 236. Why is that important? We know if your discriminant is negative, you're not going to have any real answers. You're going to have 2 imaginary, which we already know from the graph. But what we know about that algebraically is it means you're going to have I in your answer. So each of your little problems are going to have i's in them. Let's go on and finish this up a little bit. If I want to reduce radical negative 236, remember I got to find the perfect square that goes in to 236. It happens to be 4 59 times. So I'm going to reduce this Negative 1 times 2 squared times 59. The 2 squared, again, the square and the square root, they cancel. You got 2. The negative 1, that's your I that comes out. The 59, it has to stay on the inside. Let's use this in your formula. 4 plus or minus, instead of your radical, 2i radical 59 over 14. That's actually your answer, but again, to make it equivalent to most tests, you have to reduce. 4, 2, and 14. 4, 2, and 14, they're even. They're divisible by 2's. So 2 plus or minus 1i radical of 59 over 7. Okay, that's your answer. The only other thing that you could do to this answer would be to separate your plus and your minus sign to have two individual answers. That is the only other thing you could do for this problem. Two imaginary answers match the graph that did not touch the x-axis, so you know you're correct. So again, 3 cases of what the quadratic formula can do. Study those 3 cases, they're very important.